Hello everyone, welcome back to the lecture. Now we'll try to see some high-rise building structural drawings. So this is one of the building. It's a 4 basement plus ground plus 23-story building. I don't have a complete drawing with me, but whatever is there, I'll just try to explain it. Okay. So this is a plan of that. It's not a complete plan. Right now I have only a ground floor plan. Okay. So a ground floor plan means below that 4 basements are there. That slab, that plan I don't have. That is why the level is 1,800. That is 1.8 meter from here. Okay, now, yeah. So see here, there is some nursing home lift lobby here. So these are the lift lobby, what you can see from here. And then this is the administrative reception here. There's one toilet area here. Just try to see that's enough. Don't try, think too much because I don't have a complete drawing. Okay, yeah. Then they have a 1500 wide corridor here, this portion. And then all these are the living hall. Then there is a toilet and all. Then again, they have a staircase in this area. And apart from that, okay, these are the lift. So 1, 2, 3, we have 3 lift here. This is a residential lift lobby we have. Then there's a taxi stand in this area. And apart from that, there is one nursery school and a school here. Okay, and then there is a community school in this area. There's a play area here. So this is I mean, there is some commercial buildings here, like there are a lot of shops here. Okay, so all these are the shop, a very, very huge building it is. So this is how that entire plan is all about. And there is a ramp from this side. It's written a ramp up from the basement, from the upper basement first to ground floor, and all these things. And that's it. Okay, and there is one petrol pump. It should be petrol bunk, not pump. It's a petrol bunk here. Anyhow, a small understanding of the plan I've given, because since I don't have a complete plan, no, I also cannot explain it in a proper way unless I don't have a complete plan. But anyhow, a small understanding we have got. No? So this was about the plan. Now, for the same building, we'll try to see how the structural plans are done. I don't have a footing drawings and all, but I'll show you the column layout for this. See here, the building is designed for 4 basement plus ground plus 22 typical floor. It is mentioned. Okay, fine. It's actually 26. In one more drawing, it is mentioned 26. So here it is showing only 22. But if I show you one more drawing, it was mentioned 26. Yeah. See here. This is one more. Actually, when you construct a high-rise building, there will be different block A, block B, and block C. So this particular building, whatever I'm showing you now, so this is a tower. I mean, there are different tower A, tower B, tower B, tower B, tower C, or 1, 2, 3, and all. So this is tower 5. In that tower 5, you have that 4 basement plus ground plus 25-story and a terrace. But right now, the one which I was showing before, it has only 22-story. It's okay, no problem. Yeah, it has only 22 typical floor. So again, you see here, just try to understand the grade of the concrete is M60 grade of concrete we are using here. Since it's a high-rise building, we are using M60 for the first time in our life. In this entire 30 hours, we are seeing a grade of concrete more than M35 years. So this is M60 grade of concrete. The size is 500 by 900, the column size, and you're supposed to provide 32 diameter, 16 number of bar. So that is a rough foundation. Of course, high-rise building and all will have a rough foundation. We don't use isolated footing and all. Okay, so it's written rough. From the raft level, it will start up to the basement. Next, from the raft to basement, it is. Here also again, same thing. You're supposed to use a M60 grade of concrete. Size is 500 by 900, 32 diameter, 6 bar. So what is this Z and D1 dia? Again, this Z and D1 dia indicates that it's your confining and non-confining zone. So you're supposed to provide 10 diameter bar at 100 mm center to center. This is your lateral ties everywhere. Okay. So in this way, it will go like basement 3, basement 2, then lower ground floor. Then we have ground floor. We have story 1, story 2, story 4, story 5, story 6, story 8. So this way, different story up to how many? Up to story 13. He has given it here. And as you go on the higher floor, no, your grade is decreasing. See here. So it was M60. From M60, it came to M55. In the story 6, you are supposed to use M55 grade of concrete, M55. Then it came to M50. Then it came to M45, 45, 40. Why that will happen? See, usually your axial load will be more at the lower floor. As you go upwards, no, what will happen? The axial load on the column will be less. So since column is a compression member, if you're increasing the grade of the concrete in the column, your load carrying capacity is going to increase. So that is the reason, since in the basement level and all, we require more axial load is coming. So because of that reason, what will happen? You require more capacity of the column. So since column is a compression member, will increase the grade of the concrete. But when I go upwards, when I go to the, let us say, story 7, story 8 and all, you see here, this is story 9, right? Here you are brought it to M50 grade of concrete, because here the axial load is less in comparison to your lower floor. Since your axial load is less here, so less load will come in, so less load carrying capacity is required. So instead of unnecessarily increasing the grade of the concrete, we have brought it down to M15 grade of concrete. We haven't reduced the size of the column. Size of the column is 450 by 900. Even from the bottom it was 500 to 900. But when you went up a slight 50 decrease, we have done it. Okay, but we'll try to play with the grade of the concrete. That is the main intention in a high-rise building. And especially in the column, you will change the grade, because column is a compression carrying member. So, and concrete is strong in compression. So if you increase the grade of the concrete, your compression carrying capacity will increase. So that is fine. But in case of beam and slab, we will not change the grade of the concrete, because your beam is a flexural member. There you will have tension and compression both. Okay, whereas in your column you're having a more compression, it's a compression member, so you can increase the grade to increase the load carrying capacity. Okay, see, these things we do in a high-rise building. Small building and all, we don't do like this. Keep same grade, because when you change the grade of concrete every time, no, there's a lot of confusion on the side. So you have to be very careful on the side while doing the concreting. For example, say, imagine, of course, when you're working on such projects, you'll have enough experience with you. But imagine in the 10th story, you're supposed to use M50 grade of concrete. In the 11th story, you should be careful that you have to order M45 grade of concrete. Here, if you don't order M45 and if you order M40, then again, it will create a problem. Okay, so these things you should be very careful on the side. That is why for small structure and all, we don't play with the grade of concrete too much. Same grade throughout the structure will keep. But in high-rise building, you should keep economy in mind also, because when you do such things only, then the cost of your structure will come down. See, you could have kept same grade throughout your structure, throughout your column. You could have taken M60 from basement, from footing up to the top floor. You could have kept M60, but grade of the concrete M40, 45, the cost will increase. So unnecessary, you should not increase the cost of your building. Being a structural engineer, the first intention is to make your structure safe. Second is economical. By giving so and so reinforcement and column size, we have made it structurally safe. We have to make economical. Now by the decreasing the grade of the concrete, we are making it economical. Okay, and also we are changing lot of reinforcement. You see here, first we started with the how many diameter bar? We started with 32 diameter bar, 16 number. But when you went out, when you went up, no, here you are doing 25 diameter 12 number, 32 diameter 4 number. So the moment you go to the last floor, what is happening? We are going with 20. We are going with which one? Yeah, we are going with 16 diameter 16 bar, 20 diameter 4 bar, 16 diameter 12 bar. One thing you have to remember, I told you in the initial classes also, whenever you're going to the upper floor, only the diameter of the bar will change, but the number of bar will remain the same. See here again, how many number of bar we have here? 32 diameter bar is fine. 16 number we have, no. By the time you reach to the top also, see, again, but you can change the diameter, like you provide 20 diameter 8 bar, 16 diameter 8 bar. 8 plus 8 is 16 bar. Come to the top. You're providing a 16 diameter 16 bar. Still it is 16 bar. Here you're providing 16 diameter 12 bar, 20 diameter 4 bar. So 12 plus 4 is 16. Because you should not change the number of bar. Okay, if you change the number of bar drastically, then lapping and all, it will create a problem. So unnecessary, you have to give additional bar and all. So in order to avoid all this confusion, we'll keep the number of bar same. Only we'll try to play with the diameter of the bar. Okay, that's it. So this was about the column reinforcement. So I explained you for one column, that is this particular column. In this way, all the columns are there. You have to just go through this drawing. You will be able to understand. What I'll do, no, I'll be giving you this one drawing. I cannot share all the drawing. This one drawing I'll be sharing with you. You can go through this. You'll be able to understand. Okay. Apart from that, they have given some other things here. See, what do you mean by this? It means that whenever you're having, see, already this thing I'd explained you. Suppose if this is the size of your column in the lower floor, and in the upper floor, let us say your column size you want to decrease. So your column size, your column size reduced from there. So in that case, what you're supposed to do, whatever reinforcement you're taking, of course, I'd explain this, whatever reinforcement you had brought from here, no, from the lower floor, this has to be given enough development length it has to come like this, and it has to get enough development length. And here, if you want to increase, here if you want to give some additional reinforcement, then you should bring the reinforcement like this. From here you have to start. Wait, I'll delete this and I'll do. Okay. Yeah. So from here, if you want to give additional reinforcement, it has to start like this, like from here. Yeah. Suppose, let us say you want to give additional reinforcement from here. So this reinforcement, whatever you are bringing, this reinforcements. So it has to go from the top of this slab, it has to go 1.5 times the development length. This length should be 1.5 times the development length. Okay. So all these things you are supposed to follow on the side. Okay. So this is one type he has given. Apart from that, he has given here another type. This is another type of that. Same thing. Whenever you're stopping any rebar in the column, you have to give proper development length and you have to stop it. Okay. So that is what he's trying to tell. And when you are inserting additional reinforcement in the column, so then when you this is the additional reinforcement, then this distance from here to here has to be 1.5 times the development length. Suppose, let us say your development length is 600 mm, just for understanding. So 600 into 1.5, it will be 900, no? So this length should be 900 mm. So this much 900 mm, you have to embed. This much 900 mm length of rebar has to be embedded into this particular column. From here, you have to raise the column. That is how it is to be understood. Got it? And same thing here, whenever you're bending the bar, the bend should be like this. And this slope should not go more than 1/6. Like you brought a bar and now there is, you have to give a crank like this and you have to take the bar. So this slope should not be more than 1:6. That is for every 6 mm rise, the slope should not go beyond 1 mm. For every 6 mm height, the slope should not be more than 1 mm. Okay, that is the meaning of it. Slope not more than 1/6. For every 6 mm rise, you can allow max 1 mm slope. Got it? No? Yeah. Always remember, sometimes what happens when you bring a bar and if the slope you are not able to maintain, no problem. You stop your bar here only. You stop this bar here only. Insert a fresh bar from here and give a lapping here. Insert a fresh bar here and give a lapping here. Not like this. You have to give proper lapping. But anyhow, insert a new bar here. And yeah, how shall I give the lapping? Okay, here I cannot give lapping. How shall I give the lapping? Okay. Okay, anyhow, insert a new bar from here. But whenever you're inserting the new bar, no, this from here to here, it has to maintain 1.5 times the development length. That much length you have to insert in this particular column. Got it? So sometimes if it is not possible for you to crank this bar and take, then you can stop this bar here only. The new bar has to sufficiently go inside this particular column. Okay, so that the proper amount of tension is developed over there. Yeah. So this was about the column reinforcement and all. I'll show you one more drawing. In the same way, this is for the beam detail. Okay. So again, beam is very simple. I'll not explain. Just by looking at it, you will be able to understand. This is B15 beam. Then they have given the size of the beam. Breadth of the beam is 500. Depth of the beam is 1500. Then they have given the reinforcement. Bottom reinforcement, top left, top middle, top right. Look at the reinforcement here. They all are using 32 diameter bar in the beam. 32 diameter first layer, 32 diameter in second layer, 20 diameter in the third layer. Again, all these things, top middle 32 diameter 3 bar will go straight. Your top left extra will be 25 diameter 2 bar and top right will be 25 diameter 2 bar and again 25 diameter 2 bar. That means 32 diameter 3 bar will go straight. Then in second layer 25 diameter 2 bar will go straight and in this is your bottom reinforcement and this is your stirrup. So stirrup you are supposed to provide 10 diameter bar at 100 mm center to center, 10 diameter 100, 10 diameter 100 throughout the span. But it is a 3-leg stirrup. So whenever you see 3-leg stirrup, it means that how do you understand? So this is a 2-leg stirrup. Along with this, you are supposed to provide a link also. So if you provide a link in between this like this, so it becomes a 3-leg stirrup. So this will be your 3-leg stirrup. Okay. If you're not understood, I'll draw it clearly. This is 2-leg. This is 2-leg stirrup. Since it is mentioned here 3-leg, so you'll provide one more bar like this. It will be 3-leg stirrup. So this is the kind of stirrup you're supposed to provide. Okay. Since the beam is heavy and all, no, you're supposed to take care of all these things. Understood all these things? So this is how you're supposed to. I'll provide you this drawing also, no issues. I'll remove all these things and I'll provide you this drawing. I'll provide you this column schedule drawing also. Go through the drawing so that you'll be able to understand In case if you're not able to understand anything, just WhatsApp, just tell me, I'll explain you. But if you go through this drawing, no, you can at least work in some high-rise building projects and all. So those things and all are covered. Here we'll see some other column reinforcement. See, yeah, we'll try to understand this column reinforcement. So what is the size of the column? 600 by 1500. And how do you understand this reinforcement? It's very simple. So for that, you need to understand this. It indicates that this 2 bar is 25 diameter 2 bar. Again, this 2 bar, you're supposed to provide 25 diameter 2 bar. Then again, this 2 bar, you're supposed to provide 25 diameter 2 bar. Again, this 2 bar, you're supposed to provide 25 diameter 2 bar. Apart from this, whatever bar you have, no, that is this bar. He has shown it like this. This much bar, whatever you have providing, all this bar. The one which is inside the blue color, all this bar. So this has to be 16 diameter, 20 number of bar. So this is how you are supposed to understand this drawing. Now coming to the lateral test. Lateral tests are very simple. We know that. How to understand? One is your main ring. This is that main ring. This is your master ring. After the master ring, this is your master ring. After the master ring, you have to provide one more ring in the middle. Wait. Yeah. This is your master ring. After master ring, you have to provide one more ring in the middle. This is that another middle ring, which is mentioned here. Apart from that, one link you can see. Link I'll come back to later. Then this ring you're supposed to provide. So that ring is like this. Here you'll provide. Then this ring you're supposed to provide. That ring is here. And then you're supposed to provide this ring. That ring is here. And after that, everything is done. One more link you're supposed to provide. So this is a link what you're supposed to provide like this. Like this. So that link is mentioned here. Here. Like this. Understood? No? How many are there? Altogether, you're supposed to provide this. So it's a 10 diameter at 75 center to center spacing you're supposed to give. So whenever you see in the drawing that your spacing is very close, like 7500, so that will come in the confining zone. That is from the bottom of the beam, from the top of the beam, L0 distance, you're supposed to provide this. Middle, you will increase the spacing. Okay. Understood how to read this drawing? So if you understand this, rest all drawings you can read. You can easily read. All these things you can read. No need to explain again. So this is that meaning. Okay, or whatever bar you can see, this will be 20 diameter, 22 number of bar. Now we'll come to this one. What about this one? This is also very simple. How to understand? Simple. The width of your column is 230 and the length of your column is 4590 mm. Okay, fine. Then how to read the drawing? Very simple. So yeah, how to do that? We'll do it like this. So here it is mentioned. This whatever bar you can see here, no. So here we'll be providing a 20 diameter 10 bar. So 1, 2, 3, 4, 5. 5 is 10 is done. Same thing here. So whatever you can see inside this, it's a 20 diameter 10 bar. Then whatever bar you can see inside this one, this inside bar, whatever you have, they are all 16 diameter 6 bar. Whatever bar you can see inside this one, all these are your 16 diameter 16 bar. This 2 bar will be your 12 diameter 2 bar. It's mentioned here. This is understood. The grade of concrete, you're supposed to use M40. Now coming to the lateral ties. So lateral ties we'll understand. Lateral ties, again, how we are supposed to do? See here, lateral ties. One is again your master ring, which will go throughout. This will be a master ring, which is mentioned here. Wait, not like that. No, it's not like that. So this is one master ring, which will be like this. So that is given here. Where it is given? This one. Okay. This is that one ring. Fine. After that, one more yellow color ring, you have it here. One more yellow ring, you have it here. Which is that ring? This ring. This ring is that yellow ring. This ring is that yellow ring. Then you have this ring. 1, 2, 3. So that you can see here. 1, 2, 3. Same thing. 1, 2, 3. Same thing. Where it is? Yeah. 1, 2, and 3. Apart from that, you have this one link left out. No, this is that one link. Another link you have. You can see one link here. You can see one link here. So this is how you're supposed to understand. Then how to provide this reinforcement, that lateral ties. This bar, whatever you have, no, all this bar, which one, the red color, whatever you have. This you're supposed to provide of 8 mm at 75 mm center to center spacing. This 8 mm at 75 center to center spacing. This bar and this bar should be 8 mm at 150 center to center spacing. So this will be little difficult to provide on the side. That means this red color, whatever you can see here, this will be spaced at 75, 75, 75, 75. Whereas this bar will be placed at 150, 150, 150. Okay, so two different spacing in the same lateral ties, you're going to do that. Okay, so this is how you're supposed to do it on the side. That's it. So I hope this is also understood. If you understand this, rest all things are very simple, nothing much complicated. So what I will do is I'll be providing you this drawing. I'll be providing you, even this drawing also I'll be providing you, and I'll be providing you this drawing also. Just go through all this drawing so that you'll have a good knowledge from here. This is enough. Apart from that, I think one more drawing is, yeah. We'll see this drawing also and finish it off. So it is mentioned here, the building is designed for basement plus ground plus 25 typical story and terrace. Again, same thing. Okay, here you see the reinforcement now. So you'll just have a, see what happens, see here, the size of the column is 230 by 1925. Grade is M55. Okay, I'll come to this a bit later. See here, you're supposed to provide 25 diameter, 16 number of bar, 20 diameter, 64 number of bar, 16 diameter, 32 number of bar. You count what is the total number of bar that is coming. 64 plus 32 comes out to be 96, right? 96 plus 6 is 102. 102 plus 10 is 112 number of bar. Just imagine 112 number of reinforcement is going to come in this particular column. And the grade is M55. What about the lateral ties? Here they have mentioned the lateral ties. One is Z bar and D bar. That means confining and non-confining zone. Both you are supposed to provide 75, 75 center to center spacing. Understood? No. Now come to the next floor. This is first floor. See, this is a high-rise building. In high-rise building, I mentioned there are different tower. No. Right now I'm showing you for the tower 5. This is the tower 5 drawing. Okay. Yeah. Again, see here, you're supposed to provide 25 diameter, 12 number of bar, 20 diameter, 56 number of bar, 16 diameter, 44 number of bar. Again, the number of bar is more than 100. There are 100 number of longitudinal bars in one particular column. Just imagine the amount of reinforcement that you have in the column. Since it's a high-rise building, this kind of drawings you are going to see. Got it? Understood, right? Again, I'll be providing you this drawing also. Go through the drawing. And if in case you are not able to follow anything, get back to me. Rest all things remain same. Then all these other lateral ties and all that, you know how to understand all the lateral ties. Okay. Yeah. Then this is a general drawing that is given, which you already seen that. I'll not explain it again. This is all understood. Fine. So that will, again, this is very simple, not required. So yeah, so that will bring us into this particular high-rise building drawing. See, high-rise building drawing will be like this only. There will be a lot of reinforcement, okay, and the sizes of the column will be bigger, grade of concrete will be higher and all. So when you start to work on such projects in future, if you get to work, so if you have this much understanding, no, you'll have confidence to work. So whatever is possible from my side, I've covered it here. So in future, I'll be taking a few more other drawings. We'll try to understand that. So I'll see you back in the next lecture. Thank you.